Okay, there we are working on the Unit 11.2 notes. This is going to be the area of regular polygons. So this first part, the learning target is just I can find the area of regular polygons using the apothem in the perimeter. So a couple of these words may be new to you, like what is a regular polygon and what is the apothem, and then it has some familiar words as well, such as perimeter. But this first part talks about what is the apothem. So we have three regular polygons right here, and the regular polygons are just simply going to be polygons that have the same sides, so all congruent sides, and all of the angles are congruent as well. So those shapes must be convex, and we kind of talked about regular polygons last class, and so we're going to be working with them a lot today. So it just simply says the apothem connects the center point, so this point, to the midpoint of the side. Remember, just the midpoint is going to be right in the middle of one of the sides. So you just simply connect those two, and your apothem is going to always create a right angle with the side. All right, so that's important to know. We'll be using that right angle. All right, we're going to do the same thing for this. So it's just going to connect at a right angle at the midpoint of the side. And you can also draw it on, to any side. So like this is also an apothem. They are both apothems. And the last one, the middle of one of the sides. So this is the side. The middle of that side is there. Just connect these two. So another thing that's important is like these two are congruent to each other. That's something that you'll need to know as we go through this. But the apothem is just simply the line that connects the center point of the polygon to the middle of the side. So I will highlight each apothem. Alright, now that we know what the apothem is, we can use it to find the area, and the reason you need to know that is because here is your formula. A equals apothem times perimeter. So apothem times perimeter divided by 2. That's what that A and the P stands for. So we're going to start just by drawing in our apothem. So we are going to connect this to the center of one of our sides, and then remember that this is at a right angle. Okay? And then another thing that you will know is these two sides are congruent, right? So if one side is 10 units long, each of these are going to be 5. All right, and then this says step 1, solve for the central angle. So to figure out this length, we're going to have to use this right angle. And we've been doing this for a long time in geometry. We've been using the Pythagorean theorem a lot, right? We've been using trig a lot. Well, we're going to use it again. We're going to use some trig to solve. But what we need for that to work is a triangle. So what I'm going to do is connect the center to one of the vertices, okay? The center to that vertex. And what this does, it creates a right triangle where you can solve for this apothem, which you need for the perimeter, or you need for the area. So you need the apothem, you need the perimeter. So we are looking for this apothem. We need to figure out what this angle is. We know that this side is 5. What is this angle? Well, that is the central angle And how you solve for this is 360. So just think of this as like, this is a circle. And you divide it by 2 times the number of sides. All right, so 360 divided by 2 times the number of sides. And count your sides. 1, 2, 3, 4, 5 sides. So 360 divided by 2 times 5. 360 divided by 10 is 36. So we've got 36 degrees for this angle right here. Cool. So we have our angle now. We have the side we're looking for, and we also have this side length right there of 5. We're only looking at this triangle that's within the pentagon right now, because our next step is to solve for the apothem and the perimeter. So A equals what? Perimeter equals what? Which we're actually going to be able to solve for our perimeter before we get to the apothem. So our perimeter, there are 1, 2, 3, 4, 5 sides on this pentagon. So it's simply just going to be 5 sides times 10, or 50. But to find the apothem, you're going to have to use trig. And I know, thought we were done with this, but you're never done with trig. It just keeps popping up. So remember our steps. You're going to circle your reference angle. So 36 is my angle. And then we want to label these 2 sides. So I do not have the hypotenuse. The hypotenuse is across from the right angle, but I don't have that. What I have is the adjacent side, which is right next to it, and the opposite side. So write this down. Write down your SOHCAHTOA. I need to get rid of this. There we go. So we've got to figure out which one of these are we using. We have the opposite and we have the adjacent, and we're looking for the adjacent. So we're going to use tangent this time. So tangent of our angle, which is 36, is going to equal to the opposite 5, excuse me, over the adjacent side, which is x. All right, it's been a while since we have looked at this with x on the bottom. I feel like a lot of our examples last unit had x on top. So remember, with x on top, we would multiply, but if x is on bottom, we are going to divide. So the x would equal 5 divided by tangent of 36. And the reason you're dividing is because x is on bottom. So we're going to take our calculator. 5 divided by tangent of 36. So it's going to be 6.9. Right? And we'll go ahead and round this to the nearest tenth. Okay? And the reason it's 6.9, so it's 6.88, but that second 8 rounds it up to a 6.9. 6.9 is going to be our apothem. And now we have done this step. We've solved for the apothem and the perimeter. We're on to the last step. We just calculate the area. So we just plug these 2 numbers in. So our apothem is 6.9. And then our perimeter is 50. And we divide all of that by 2. So 172.5 is what we get. There's no units on here, so I will just say units squared. All right, now for this one, follow the same pattern. We have our right triangle. Once we draw in, this is actually called the radius from the center to one of the vertices. And now our apothem is 1.7. So this right here is 1.7. We are now looking for our side length. Okay, why are we looking for our side length? Because we need the perimeter for step 2. So that's how we know what we're looking for. But we need this angle as well. So our central angle is going to be step 1. So 360 divided by 2 times 6, because there's 6 sides. 1, 2, 3, 4, 5, and 6. 360 divided by 12 is going to be 30. So this is 30 degrees right here. All right. We have 30 degrees. We are looking for our apothem and our perimeter. We already know that our apothem is 1.7. So we can go ahead and write that in. Easy. But now we have to do trig to solve for our, this piece, so we can ultimately find our perimeter. All right, if this side is 1.7, I'm just going to go ahead and write that so it's closer. That side is 1.7. Here's my reference angle. X is opposite of this angle. It's way on the other side of the triangle. 17 is the adjacent side because it's touching this angle. It's right next to it. We don't have the hypotenuse, and so we know that we want to use tangent again, because tangent is opposite over adjacent. So tangent of our angle is equal to x, which is the opposite, over 1.7. All right, this is a little bit different. Remember last time x was on bottom, so we divided. This time x is on top, so we're going to multiply. So x is going to equal 1.7 times tangent of 30. And that's what's going to go in our calculator. 1.7 times tangent of 30. Okay, so it will end up being 0.98, so 1 is going to be what the side length is, 1.0. Because that 0.98 will round up to 1. So we know that if half of it is 1, remember these two sides are congruent to each other. So if x is 1, then the entire side length is going to be 2. All right, and then there's 1, 2, 3, 4, 5, 6 sides. So the perimeter is going to be 2 times 6, or 12 units long. Didn't leave enough space for that, but 12 is going to be the perimeter. So we have our apothem, we have our perimeter. This is a much smaller shape because each side is only 2. And we're ready to calculate our area. So our apothem is 1.7. Our perimeter is 12. Divide all that by 2. So 1.7 times 12 divided by 2 is going to equal 10.2. Units squared. All right, almost done. On to the last problem. Now we have an octagon. Some of you look at it and you're like, no, that's a stop sign. Oh, same thing. All right, this time you are actually given the radius. So we need to solve for both the apothem and the side length over here. Our central angle is just simply going to be, plug in 8 there. 1, 2, 3, 4, 5, 6, 7, 8 sides. So 360 divided by 16. It's 2 times the number of sides. If that happens to you, if you need to, these calculators aren't giving you the right answer, 45 divided by 2 is what it's simplified to. You can always just do 360 divided by 16, and then before you press enter, click control and it'll give you the decimal answer. But 22.5 is our angle, so I'm going to write it in sideways. 22.5. It's kind of hard to see, but I'll write it big over here. So that's your central angle. And then we need our apothem and our perimeter. So 6 is neither one of those. It's not going to, help us solve for the apothem or the perimeter. We've got to use trig to do that. So let's start with the apothem. So we've got x is our apothem, 6 is our radius, connecting the center to one of the vertices. And here's my reference angle. And then x is going to be adjacent to that. 6 is going to be the hypotenuse. So that's my trig key. So if I have A and H, I want to use cosine. Cosine of (22.5) equals the adjacent side, which is x, over the hypotenuse, which is 6. So we are going to multiply. So x is going to equal 6 times cosine of 22.5. So we're going to get 5.5. And that's our apothem. All right, so we have our apothem. Now we've got a couple of choices. We can either do trig again, or we can do Pythagorean theorem. I'm going to choose to do trig again. And that way we're just always doing the same thing. But if you wanted to, you can use Pythagorean theorem. So now we know that this side is 5.5. This is now, I'm going to call it y, what we're solving for. So y is your opposite side from this angle. So now we have O and H. And I would suggest use this number because that is a whole number. It's not rounded, so your answer is going to be more accurate. So opposite over hypotenuse. For the second one, I'm using sine. All right, so sine of my angle equals x, or sorry, not x, it's y, because that's what we're solving for, over 6. And then we will just multiply 6 times sine of 22.6. Six times sine of 22.6. So we get, for this apothem, we get 2.3. Or not this apothem, sorry. For this side length, you get 2.3. Now we can use this number to find the perimeter. But remember, if y equals 2.3, then this whole side right here is going to be 2.3 times 2 for 4.6. All right, so 4.6 is one of your side lengths. Oh, that was out of the screen. All right. So now we can find our perimeter. So one of the sides is 4.6 times 8 sides. (4.6 times 8 is 36.8. And that's going to be our perimeter. All right, now we have everything we need. We've got our perimeter. We've got our apothem. Let's just plug those in. All right, and so we are going to plug in our apothem and our perimeter. So the area equals 5.5 times 36.8 divided by 2. So 101.2. All right, and that's it.